Hello and welcome to Calculus 2 here at Cañada College. My name is Lapuz. In this video we'll do checkpoint 6.22 from section 6.4. It says to use the first five terms of the Maclaurin series for e to the negative x squared over 2 to estimate the probability that a randomly selected test score between 100 and 150 to estimate the probability of that, and then use the alternating series test to determine the accuracy of this estimate. All right, we're going to need a few pieces of information. Let's start with the series itself. We know the series for the exponential function e to the x, so let's write that down. E to this x is going to be, well, let's write down just the terms of the series, and then we'll look at it from a summation point of view. So the series looks something like this. We have 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus x to the fourth over 4 factorial. And we kind of get the picture. This is x to the n over n factorial, our general term. Now we want to put in negative x squared over 2. So e to the negative x squared over 2 will be the same thing, except wherever we see an x, we're going to put a negative x squared over 2. So let me write out the first 4 terms, including the 1, and I'll stop here for now. And we will put in the negative x squared over 2, negative x squared over 2, negative x squared over 2. And let's see if we can simplify that, negative x squared over 2. So this general nth term would generate an alternating series because of the negative sign. And we'll see how that works out. So we will have 1 minus x squared over 2 plus, now I will have I'll have a plus, I will have a positive, I will have an x to the fourth, and I will have this 2 squared times 2 factorial. And again, I'm not going to multiply that out just yet so I can feel the pattern happening. The next one is going to be a negative because it's raised to the third power, and I'll have x to the sixth over 2 to the third power times 3 factorial. So now I can see that pattern. This is going to be negative 1 to the nth power. That's the negative being taken care of. That makes the alternating series. I have x to the 2n up on top, and then this 2 to the n in the denominator along with the n factorial. And I can verify all the other terms that I've had before that it looks pretty much just like that. All right, now we will want to integrate this. So let's take it step by step. We're going to want to integrate it, we're going to want to evaluate it, and you're going to multiply by 1 over the square root of 2 pi. So let's first do the integral. So in integrating this dx, we integrate each of these things term by term dx, which means we integrate this dx without the limit yet. And what we'll get is the integral of e to the negative x squared over 2 dx will be equal to the antiderivative of 1 is x. The antiderivative of this is going to be, now again, I'm going to keep my numbers separate. So this will be x to the third over 3, and then there's a 2 down in the bottom. Here it's going to be x to the fifth over 5, and then there's a 2 squared times 2 factorial on the bottom. No good way to combine that, so I'm going to leave it like that as is for now. Negative x to the 7th over 7 times 2 to the third over 3 factorial. And you kind of get to see the 2, the power for the 2 is going to be like your n, and then the 7 would be like 2n plus 1 or something like that. But we'll see that here. Negative 1 to the n is a constant with respect to x, and so you'll have x to the 2n plus 1 over 2n plus 1. That's the integral part. And then the 2 to the n and the n factorial are constant in the denominator, so they'll stay in the denominator after you integrate. So this is your antiderivative. So now we're going to put in the values. They say they want to go from 100 to 150. So in terms of analyzing that, this is these are like your well, if you've taken statistics, it's like the z-score that puts you back down to the standard normal distribution. So our lower limit will be 100. So if a is equal to 100, you will have 100 minus mu. By the way, for the IQ test, I guess they're doing the IQ scores, and they didn't state it explicitly here in this problem, but in the problem before, they included the fact that the mean for the IQ scores is 100. And the standard deviation for the IQ scores is 50. Or maybe these aren't IQ scores, maybe they're just regular scores for something. All right, so now that we know that, we'll use that for the mean. So it's 100 minus mu divided by 50, and so that is going to be 0. So the lower limit here will be 0. Now the upper limit is 150, so it's 150 minus mu, which is 100, divided by 50, so that's 150 over 1, or that's 50 over 50, excuse me, which is equal to 1. And that will be your upper limit. So we'll use that to integrate here. We're going to integrate from 0 to 1. So this is an a of 100. That's going to give you a z-score of 1 or 0. And this is a b of 150. It's going to give you a z-score of 1. So those are our limits. We have e to the negative x squared over 2 dx. We already integrated this, so we'll just, I'm not going to rewrite the whole thing. I'll just maybe put some quotes here and say, hey, we're going to integrate this from 0 to 1. And notice that if you put 1, if you put 0, we're going to get 0 because all these terms have an x in it. So let's just put the 1 in there. So this is a 1 minus 1 over 3 times 2 plus 1 over 5 times 2 squared times 2 factorial minus 1 to the 7th power, which is 1, over 7 times 2 to the 3rd times 3 factorial. Now they say, how many terms do they say? Use 5 terms. So I got 1, 2, 3, 4, and the 5th term, if we notice, it's going to be positive, negative, positive, negative. So the next term will be positive. And then it's the next odd number, 3, 5, 7, and the next odd number is 9. We're going to have 2 raised to the, this is 2 squared, 2 to the 3rd, so this is going to be 2 to the 4th. And then this would be the same as a power factorial. Okay, and then I'll put dot 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 here, but if they only want the first 5 terms, then this is what we're going to go for. Okay, so we're only going to care about this much of the series. We know that this thing goes on forever and we'll deal with more stuff later, but let's figure out the series. Now the actual probability is has this formula where you have to multiply by 1 over root 2 over pi. So the actual answer here, the probability that your value falls between 100 and 150 is going to be given by this integral that's 1 over root 2 pi times the integral from 0 to 1 of e to the negative x squared over 2 dx. Okay, and so we will take this value over here and then multiply that by negative pi over 2. So that value over here, I looked it up already and calculated it, and we got that value to be this. And so all we have to do is multiply this by 1 over the square root of 2 pi, and then multiply this by 1 over the square root of 2 pi. So let's do that real quick. And our Desmos, let's put this all in parentheses, and 1 divided by square root of 2 pi. And this will give us a 0.3413. So this is our final answer for approximation. So that's the probability that we're looking for. The next term, or the next idea that they want, is this function. They want to know how close is this to the actual value. For that, we need to let's box this up first. Okay, so to answer our next question, which is use the alternating series test to determine the accuracy of the estimate. What we need for the alternating series test is this value, the next term value. So using the alternating series test, alt series test estimate is to look at the next term. And the next term is going to be that term that's missing over here. So that will be 1 divided by, so if we follow the pattern, there's 3, 5, 7, 9. The next odd number is 11. We have 2 raised to the next number after 4, which is 5, and the same number factorial. And so if we punch this into our calculator, I already did, but I think I erased it. But let's say 1 divided by 11 times 2 to the 5th power times 5 factorial. We get a number that's 0.000, something really small. And more importantly, it's like within, there's at least 4 zeros there. So that tells us that our approximation is good up to however many zeros we have here. So we have 1, 2, 3, 4 zeros. So I think we're good to up to 4 decimal places. Okay. Now, one more thing to check. We can actually use this formula to figure out the exact value, right? Just to check. So let's do that. I'm going to shrink this a little bit, and just so we can see the integral. So we have 1 divided by the square root of 2 pi, and then we want the integral from 0 to 1, for our case, of e raised to the negative x squared divided by 2 dx. And this is the actual value that we have for the integral. This is as exact as however many digits are showing. And so if we take a look at that and compare it with what we got earlier, this would be a good comparison. So the exact value is given by 0.3413, and the estimated value is 0.34135. So we got up to, this went to 3.4, this went to 3.5 in the thousandths place or 10,000th place. So I think we're good. All right, so that's it. I hope that helps. Good luck.